And I really wish if I could have in the audience my inspiration and ideal, Professor T. Pradeep sir. And I always owe and remember my journey, which began in 2014 with the pure motivation of Namami Gange program, like how when Clean India was launched and Namami Gange was launched. So how as a scientist, how as a researcher we could contribute, and this led to this was the time, and also I met Professor T. Pradeep in ISC Bangalore in 2013 December. So during this time, 13-14 was the time when I really got inspired and motivated and got convinced like the nanotechnology could really make that big change.
Yeah.
And what sir has and the IIT Madras has done in the area of nanotechnology, drinking water, filters, and all that is credible. And please convey my regards to sir. And I
Yeah,
owe
sure,
my
ma'am.
this
Yeah.
to sir.
Yeah,
So to begin with, I just sharing my screen.
please. Yeah.
Is my screen visible?
Yes, ma'am.
So
Yeah.
okay. So this is my talk, and once again, I am thankful to ICCW for having me here. So thanks for your kind introduction as well. And this topic of my talk is innovative wastewater treatment and water reuse technology from this platform which we have developed. So this is the first, I'll just brief about the Center of Excellence, and then I'll come to the technology part. So this is the NMCG-TERI Centre of Excellence on Water Reuse, which is first of its kind established by Namami Ganga, National Mission for Clean Ganga, Ministry of Jal Shakti under Namami Ganga Knowledge grant. And this center is primarily, it's a technology forum where various stakeholders. So the vision of the center is to contribute in these national missions. So various national missions are there which are centered around water, and this center envisions to contribute. And we have chosen at least one objective under each mission to fulfill. And the mission of this center is to bring all stakeholders. You can see various categories are there, and all are welcome in any ways to contribute in this broad area of wastewater treatment, management, water reuse technologies, knowledge document, sharing best practices, events. Anyways, you find, and this is what the mission. It is headed by a steering committee, which is headed by DG and MCG. And the vice chairman is our DG, Dr. Vibhadavan, Terry, and others. These are nominated members from the ministries. So Ministry of Power is there, Niti Aayog, MoHUA, Jal Shakti, and now very soon Ministry of Agriculture is also going to be added. So whole idea is the areas the sectors which are water intensive and need the water reuse. So likewise, Ministry of Railways is also being inducted very soon. This is our advisory committee, and what we do, we work in these broad areas of work, right from technology development. So TEDx is just one technology. There are many other upcoming technologies which are being developed through this center, and we welcome other technologies also who could be part of this platform and could be taken for pilot in various Namami Gange projects. We also work on sponsored project consultancy. So I'll just briefly go through each of them. And this reduce. So these are the, how is it coming?
It is showing now the consultancy project, Tetra Tech and USCPA.
Sure. can you also see a small screen which is coming?
No, ma'am.
Okay, it is might be. So the first, these are few projects. We are in the third year of its running, and right, starting from the scratch, we have reached here and completed a few projects. So the center undertakes consultancy projects. So this was a World Bank funded project for Bengaluru Water Sewerage Supply Board, and here we assessed all 36 STPs of Bengaluru and assess them in terms of wastewater treatment for point of use and how appropriate technologies could be there for point of use. Then sludge treatment, how we can enhance sludge treatment for better biosolid production and utilization, likewise better biogas production and utilization, treated water reuse market plan, and to achieve all this, what are the regulatory framework or what is the change in procurement policy and regulatory framework required to achieve this. And today, any utility which is earning, let's say 16 crore per annum or whatever figure, but with A plus B plus C interventions, they can earn up to 450 crore per annum. So how to make the utilities sustainable, financially sustainable, and truly the utilities of the future was the aim of this project. This is completed and very soon we are going to release the report. Another project which the center has undertaken was another consultancy project from US EPA through Tetra Tech, where we assess the inventorization of GHG emissions from domestic wastewater sector in India. And this was first of its kind study done in detail. And the recommendations and the report was um, uh, US EPA referred to UN, and I was invited to present the findings in UN Geneva in the Global Methane Forum this year. Also, we work on adequacy reports for ZLD plants, assessment of ZLD plants. So this kind of work the center undertakes. We are closely working R&D consultancy projects with various municipal corporations on treatment of landfill leachates. Then microplastics is a core area of research these days. So microplastics in Yamuna and groundwater in Delhi, study is funded by the Department of Environment, Delhi government. Then another area we are working on the study of Yamuna frothing in Delhi. So our recommendations have been taken up and quite a lot of work has been done in this area. Also, we organize event. Next month, we are having our annual event. And also research, continuous PhD program is there. This is the first thesis which has come out from the center and many more are registered now. And these are the research publications. So our work is peer reviewed, internationally published. And also we work in the area of knowledge creation, media articles, and all that. From our own work, we publish the recommendations and all. Now coming to the technology implementation part. So what you see is the technology development. So in two sectors we'll discuss. One is the industrial, other is the municipal wastewater. So simple one slide. What you see here is the slide where you see a general scheme of wastewater treatment and the problems associated with it. And what you see on the screen is just where you find a lot of steps. You find a lot of steps here. And what we see in general, this is just one example in the domain where you see this is an example of a textile CETP, a referred study of Tirupur. So what we see in general that wastewater treatment involves a lot of steps, first of all. And then secondly, we involve a lot of physicochemical. We involve a lot of physicochemical methods, which involves a lot of chemicals. We have to remove this. Just a minute. This, how is it coming? ये press करना, this one. And this, how to remove this? Thank you. So what we see here is the physicochemical treatment, and we all know this step involves a lot of chemicals. And when you visit CETP anywhere in the country, they are putting literally after a few hours with the change of shade, 6 bags of like this chemical, another 6 bag of another chemical, just because the shade is much darker. So this is the way we are treating and using excessive chemicals, and this is the result. We end up with 30 to 40, more than 40 in some cases, kg of sludge per meter cube, and which is hazardous, toxic and hazardous sludge. So this is one area. The second problem with our wastewater treatment, particularly in the industrial sector, is the biological treatment. So we involve a lot of our biological system. Generally, they are shock prone, and simply with a change of shade from morning to evening, our biological systems, they get disturbed. So ultimately, after biological, we are sending water through sand filter, carbon filter, and ultimately this kind of inadequately treated water generally comes out through drains and reaches our rivers. So this is a very common phenomena seen here. And then MSME has no choice. They discharge this kind of water. Whereas large industries who can afford, who are part of CETPs, they have a tertiary treatment system where this colored water goes as the RO feed. And we all know from here comes the expenses and RO reject. It has RO reject, associated problems of uh, choking, fouling of membranes, and here comes the expenses. Then RO reject goes into multi-effect evaporator. ME also has a reject. Further, there are MVR and other technologies also which are working for reject management. And ultimately, we are led for solar drying or any mixed salts which we are unable to use. So, how unsustainable is the process? Even if we are able to achieve ZLD, see, this is A, we are starting from here, and ME condensate, B. If we are able to achieve ZLD, just imagine at what cost and how unsustainable the whole process. We are simply converting the pollutant from one form to another. So, and when it comes to cost, on average, I'm discussing textile CETP to achieve ZLD, it's average rupees 250 to 275 per KL treatment cost. In case of pharmaceuticals, the cost is around rupees 1500 per KL just to achieve ZLD. So these are the statistics which is there, and this is the reason why ZLD is taboo and industry is not willing to adopt. So as scientists, as researchers, it's a responsibility to come forward and help. And with this intention, we came forward. And now another second scenario. This was the first scenario. Second scenario, just imagine if we can somehow remove the color, because color and organics are the real problem of industrial wastewater. And just imagine, this is although a permeate, but this kind of water, had this gone into uh, as RO feed, just imagine the load on tertiary would have been reduced, right? And if this kind of water where color is completely removed, just imagine, and that kind of water, third scenario, if you imagine, if that kind of water, if we can bring somewhere at pre-biological or even post-biological, how much less load on tertiary and subsequent stages it will, and the whole process will be highly resource and energy intensive. So with this background, we developed a technology called TEDOX technology, TERI Advanced Oxidation Technology. I am the inventor, and my team, my research scholars, as a team, we have worked on this, and we have few patents and a registered trademark with the Government of India. And this is, you can see such a simple process flow diagram where majorly you can see two stages. So first stage involves coagulation and flocculation, but innovation starts from there itself. We are not using alum ferrous kinds of salts, which are the real culprits. So whole experience, whole development has gone into what not to use. So then once primary treated effluent comes out, we are simply mixing titanium dioxide kind of nanomaterials, giving contact time aeration, and passing through a photocatalytic reactor having UV light radiation sources. And this is just one chemical we are adding. No other chemical is being added here. And that too, nanomaterial is separated at source and recirculated up to a few months with some top up. The same nanomaterial is there in the system without addition of any chemical. So this is the process, and ultimately we get TEDx treated water. And what is the science? We all know it's very simple science. It's purely UV TiO2 photocatalysis, where these titanium nanoparticles having water, air, and UV light, they get they generate hydroxyl in situ, they generate hydroxyl radicals, and these hydroxyl radicals have the highest oxidation potential after fluorine, we all know, and they are able to break the bonds, the organic moieties, and once pollutant molecule is broken into small molecules and with time elongation, it is completely mineralized. So this is the simple science which is taking place, and this is the reason why our organics and color are being removed. And other benefits of this technology, we all know. We all have studied photocatalysis at early stages also. And the best part is that these hydroxyl radicals, they are non-selective, which means any stream which come to their way, they are able to treat it. And this is the reason you will come to see in my next slides, the same technology is applicable to various streams. So this is simple science. And now we come to and this technology was developed through DST Water Mission, Water Technology Initiative Program of DST, Ministry of Science and Technology. And we are at TRL 8 now, reaching 9 with the commercialization very soon. So this was the first project. This technology was funded upscale for piloting, was funded by NMCG. And our first project was given to us in a textile CETP in Ruma industrial area of Kanpur. And right across the Ganges, the untreated water was being discharged through canal. And this is, you can see such a small footprint. This TEDx plant is there, which was inaugurated last year, February 2023. And you can also see a functional plant for the process. And this is CETP textile cluster of Ruma Kanpur. Water coming from the equalization of the CETP to TEDx plant. TEDx primary treatment. Stage 2 and TEDx treated. So you can see actually photocatalysis being demonstrated for the first time at the pilot of 20 KLD. So this was a very successful project run for 7 months, and a complete life cycle analysis was also done. And you can see the direct equalization water is treated with TEDx, and these are the results from CSIR lab. And what you see here is now this was standalone, and these are the values. And as per the plan, now in phase 2, this TEDx will be integrated at pre-biological. So this is the integration plan. And if we integrate solar with TEDx, so this will have its own benefit. We'll come to that. And this is the integration plan in a textile CETP planned for this work. Next, coming the achievements of this project. For 7 months, LCA studies were done, and we were able to meet the objectives of the project. 50% capex reduction, because when you receive this kind of water, you can see when this will go to biological and further stages, it will be quite sufficient for 50% to be reused for various low to medium applications, which means, and most likely with these characteristics, our requirement for ZLD might be reduced by 50%. So straight away for ZLD, 50% capex is expected to be reduced, and already 40% OPEX was calculated to be reduced. We were able to achieve 32% GHG emission reductions in this case. We integrate solar in this, further 40% OPEX reductions, and we were able to achieve net zero targets. Also, this was first of its kind demonstration in the world of TR to photocatalysis at 20 KLD pilot scale in a textile CETP. 75% less use of chemicals was calculated as compared to conventional technologies. Sludge was the major, this was an additional benefit when we found our average values coming out to be around 0.5 kg per meter cube. So just imagine the benefit of nanotechnology, and if we improve primary as well, so we are able to reduce sludge from 30 to 40 kgs average values to 0.5 kg per meter cube. And also the sludge which we obtained in our case was tested on 88 parameters as per CPCB. TCLP studies were done and it was found non-toxic. And we were able to come up with evidence-based policy recommendations from this project. And this project won. Why is it not moving? So this project won IWA Project Innovation Award this year, and we received this. It was selected under top 3 innovations in breakthrough in R&D category, and we received silver amongst 108 entries from 34 countries. So this was the outcome of this project, and this technology has been now. We have developed more than 30 to 35 case studies, and you can see different sectors and different geographies of the country. So for an individual unit, that was a CETP case. Now this is for individual ETP. So when a company asked us to just have TEDx and then RO, no biological in between. So for individual units, TEDx was just sufficient for treatment. Whereas for a CETP, we propose it to have it pre-biological in textile, whereas in tannery, after a lot of work, we propose it to have it post-biological. So it has to be decided based on the characteristics: petrochemical, open drains, chemical manufacturing units, then again CETP, tannery, slaughterhouse, pharmaceutical, you can see. So these are the results of the work. Chemical, again, oil and gas, direct redox treatment. Just imagine the produced water, which is a huge problem for oil and gas industry. This kind of direct advanced oxidation treatment is possible. And now coming to the ZLD. So what would industry do? This is the ME condensates. The low boilers are coming in the condensate. So even if industry want to achieve ZLD, they are not able to. So again, it is our responsibility to come forward and help industry so we can have such kind of interventions at the tail. Last, ME condensates we can directly treat. So we have shown various possibilities so far. Next coming to the sewage treatment. So in this category, this was one slide. And this is a very common scenario in the entire country. This is particularly the pictures taken by myself from Gurgaon. What you see in general, rampant construction is coming up, SEZ areas are coming up, and for whatever reason, STPs are there, but they are non-functional. And inadequately treated or untreated sewage is flowing, and it is there in the open. No problem. But when the rainy season comes, they all are exposed. And this kind of water, sewage, is coming in our campuses. These are our own pictures of our own campus, TERI campus in Gurgaon. And this was the need when we thought we have to do something. And second driver for this work has been the requirement of the national missions. So we have these requirements from low to medium to high grade water. And what would utilities do? Today we have SBM 2.0, where the requirements are to have 30% reuse, 50% reuse, 100% reuse by 20. Various targets are there. Immediate is 2025, then 50. So how are we going to achieve these targets in the sewage and municipal sector? So again, here comes the role of we our such kind of interventions, and we went to Delhi Jal Board with our work, and we were given the chance to work in Rithala STP plant, and this is the result. This is Rithala STP inlet. This is outlet. So same technology, everything same. Only difference comes in the HRTs. Hydraulic retention time, of course, depending on the water quality and the industry varies. Whereas in case of, let's say, in a textile CETP, it could be 2.5 to 3 hours HRT, whereas in case of sewage, it's just 30 minutes. So that is the only difference. Otherwise, technology remains the same. And what you see from this slide is that the approach. So for greenfield projects, what we are discussing nowadays is that for greenfield projects, you can have direct ad hoc intervention in the inlet. Whereas in brownfield projects, let's say where compliances are not met, you can have a ad hoc kind of intervention at the at the polishing stages. So in both the cases, what you can see, COD less than 30, BOD less than 5, we are able to achieve amongst other parameters. You can also see the biological parameters. Also, what we are doing is we are working as a center, as a research. We are working parallelly in the area of micropollutants. So same sewage, you can see the difference, micropollutants. So today, when country, we do not have, of course, we do not talk beyond BOD, COD, and of course, we are not talking of micropollutants, but countries like Sweden, many European countries, they have the legislation on this. And so maybe we are preparing ourselves for, let's say, next 5 years, if we are able to have some standards. So this is our intervention from our center. We are working on removal of pollutants from the sewage. Then coming to another, this is our 10 KLD plant in TERI Gurgaon campus. So what you see here is a mixed sewage. Mixed means we have specially created a sump where wastewater, it's a huge 100-acre green campus in TERI Gurgaon, where all researchers, they have their facilities, pilot demonstrations, and everything is there. And we have created especially a sump for wastewater coming from research labs, hostel, canteens, toilets. And you can see direct ad hoc treatment, no stream segregation, no biological before or after or anywhere, no chlorination or any kind of disinfection. And total treatment time is 5 hours. And this is the kind of water which we are having. And this plant is running successfully since August 2020, peak of Corona. It has been established and we have been working. And this kind of water, which you saw just on the last slide, it has been tested and this has qualified various certifications for safe land discharge, land irrigation, horticulture, cooling tower makeup, green building, Griha rating, construction and housing sector. So we often come across a few reports of some societies which are being demolished simply because they are the pillars are being corroded. And the reason behind is the water which was used for construction was not of the standard quality. So here comes again our intervention as scientists to help the construction and housing sector with this kind of water. And now with these certifications, this technology is a registered product in Griha Green Building rating. So overall benefits, if we see this technology, it's truly a clean and green technology, very less use of chemicals. Sludge, you can also see values reduced from 30 to 40 kg average values, 2.5 kgs per meter cube, non-toxic sludge, direct in case of sewage, municipal sewage, direct ad hoc treatment, no biological interventions. In case of industrial, it is an integrated, retrofittable, modular approach. CapEx 50% less, OpEx 40% straight away less. highly efficient in terms of resources, energy, cost, every way. And also the water quality, we have met all the norms, NGT, CPCB, reuse norms, all these. So same technology has wide applications, which has been tested over the years. We have also demonstrated a unit, small unit, in India Water Week recently, where the live demonstration of treatment of sewage of Bharat Mandapam is being treated. You can see the beakers here. And both secretaries uh, came and visited this plant. And also, very recently, in 4th November Ganga Utsav, we demonstrated and treated live the sewage of Haridwar STP uh, in Ganga Utsav. These were few recognitions for the technology, and we have licensed our technology. So two companies have taken the license, Due Projects and Ion Exchange India Limited. And Ion Exchange is for industrial wastewater, and whereas Due is working in the area of municipal sewage. So we are open, non-exclusive license for the municipal sewage, open drains, rejuvenation of lakes, ponds. All this work has been done, and we are open for licensing and working in this area. So, with this, I conclude my presentation, and I really invite partnership and collaborations. And as two organizations, I really look forward to good work and collaboration. So, thank you so much, and I'm open to questions now.
Thank you, ma'am. Thank you so much. It was great listening to you, and a lot of the technology that we could get the latest ones going on, and it's very happy to see you. And first, many congratulations for the award.
Thank you.
And
Thank you
yeah,
so much.
we actually look forward to work together, ma'am, and because we are looking at the three major aspects that which you were talking about in today. The one is in the sludge treatment, because there are so many industries that now ICCW is also doing a lot of wastewater treatment, and we are looking at how we could treat that water. And sludge is one of the most neglected areas in many of the treatment plants. So probably that's the one part. We are also now looking at the prospects of how we could manage that sludge is one area which we are looking now. And also the microplastics which we were telling about. So we also thinking of some proposals in that regard. Microplastics, and we have one of our team member who worked with the Rameshwaram coast, so where he did his PhD on that one. And he's also interested in looking at various areas that we could, how the microplastic study can be done for different courses, and how that can be further strengthen, or just do some work towards that one. And lake restoration and the rehabilitation is the area where we are also looking at, and my PhD is on that,
Well,
on the lake ecosystems. Yeah. So these three areas, just I felt like that I would share with you, so that would look for collaborations and love to work with you. And now I request the audience, if you have any questions, please you can unmute and then ask.
They can also raise their hand, I think, so that
Yeah,
we can have some order.
yeah.
Let me ask one question, Madam. It was very
Yes.
fascinating listening to you, and I've heard this also earlier occasions as well. So one very interesting thing is you're saying it's the same technology that can be applied for different wastewaters. So could you explain how it is benefiting the MEE and the post RO treatment? Is it only from the point of view of fouling and the pre-sludge management, or is there any benefit on the TDS itself that this is able to bring?
okay, I'll just share one thing. I'll just share one thing. So I'll just share my screen. once again. So, sir, what you see here is a policy brief actually. So the answer to your question will come from here, that you are particularly asking for the ZLD systems,
Yes.
RO and all. So, sir,
Yes.
actually, problem what is happening is that the major issue is the color or the organics.
Okay.
So this is the major reason. And when you have this kind of problem, and it's not just that you are using RO for TDS. See, we are not talking of replacing TD RO. We are not talking of replacing biological. We are only talking of integrating, because every technology has its own benefit. So advanced oxidation has its own benefit of removing color and organics. So this is our strength. So if we integrate, so this is simple, I already discussed this. And if we integrate it in this is a non-compliant CTP. This is a Kanpur actual plant. And this is the kind of water. So they are using conventional biological treatment and then passing through sand filter, carbon filter. And this is the water which is going to the Ganges. So just imagine if in a non-compliant CETP, if you ask, government has two choices. Either they shut this plant, which they cannot do because a large amount of hosiery cluster. It's a huge hosiery cluster, so they cannot close it. So other option is to have ZLD. But just imagine where color organics is not going. How if they put RO, ME, whatever. Just imagine how energy intensive will it be. And of course, CETPs they are not willing to adopt ZLD simply because of this reason. So if we are able to, with this technology, this is directly from the equalization you are treating through TEDx. So the major problem of color has gone, organics have gone, and when you see BOD, COD 90%, see the color has gone, COD 75%, BOD 65%. This is on the starting date, 17 February. 17 February was the first time when water came out. And that was the day suddenly when we had a surprise visit from NMCG also. So it was almost a Chandrayaan moment for us. What kind of water is going to come out? And these are the results. And this is towards the end of the project, when in August, September it was ended, and this is 9th August. What you see is the result. So we are able to remove the color, and in the results you can see 95% COD reduction. BOD also 96%. So just imagine.
You say that, so this today we are saying ZLD is not affordable for the middle scale and maybe the micro, medium scale companies, but this would make it affordable and they can actually improve their effluent, right? And there is a payback.
Units, yes, sir, for individual units, it can directly be used. You do not require anything else. Whereas in a CETP, it has to be integrated at pre-biological. So the benefit of integration, it will reduce the load. So biological will now be more shock resistant. It will safeguard biological, and the now RO and all less choking. Only it will do. It will reduce the TDS. So TDS job will be done by RO, and rest load will be reduced. So this is.
And you were saying we were adding chemicals unnecessarily, excessive chemicals, which are affecting the bio.
Exactly, sir. These ferrous salts, ferrous and alumina salts, they form the insoluble compounds. And if when we say the sludge, when I showed you in my slide, that 30 to 40 kg per meter cube, which is an average value in a textile CTP or any coloration industry, the major component is just of the chemicals. And of course, also biomass also comes. But if we are able to better treat the primary, we are going to improve. And with this intervention in the secondary, truly we can achieve the sustainable treatments and bring sustainability in wastewater treatment. So these are the LCA. All international protocols were followed. This was LCA studies which were done. And we had 3 scenarios, you can see. Scenario 1. Scenario 2, what I told. If you ask that
Right.
CETP to adopt ZLD, they will not be able to do. Whereas if we have TEDx, just one intervention and rest everything remains same. So just imagine now they will be able to achieve ZLD with all those benefits, and you can see these are the benefits. GHG emission today internationally, we have to answer about the GHG emissions, and as a country we are not able to answer beyond BOD and COD, and that too we are also not able to achieve. So here comes the huge responsibility, and with this policy document, we have given recommendations to various ministries, Jal Shakti, what they can do. Ministry of Textiles, we have come up not just with a technology option, also it is our responsibility as a research policy organization to help with such policies which are already there with the Ministry of Textiles. And let's say any CETP wants to adopt new technologies with these financial schemes, they can have the benefit of adoption. So this can bridge the gap. This was the document.
So what exactly is preventing it from scaling up? One is you've said you've tied up with the Iron Exchange and the company, and you're open to licensing it to other organizations.
Yeah.
So basically, it's time to construct this redox treatment system. You have done the laboratory work, and it was designed for scaling up in TERI itself. So you have a complete technology even for a large scale plant. You could probably give the drawings, and you could somebody can manufacture and assemble and install, train and commission. That's how it is going to work, right?
Exactly.
So okay, so ICCW, if we were to partner with TERI on this, because we are a non-profit, but we are interested in promoting these technologies.
Exactly, sir.
One is the large companies will take it, and that is a good thing. But is there a chance of a smaller startup kind of a company taking this forward and moving it at a large pace? Or that's what would you say?
So what we are looking at this stage is because it's a new technology, complete science, everything has been done. Now we only need the engineering support. So pilots have been done as per our understanding drawings. Today we are ready until 1 MLD, 100, 200 KLD, 500 KLD, 1 MLD. And when we will have these kinds of pilots, 200, 500, we'll definitely then after 1 MLD, we can upscale to 10 MLD, and also that will take time. So therefore, we are not very keen on startups taking up, because there is always a reputational risk which is involved with the organization, with the technology, and with the startups. So we are more interested in licensing with the established water treatment companies who are well established, and they can help us with the engineering support and civil construction and all that. Rest, we are always at every step, we are there to work on this. This is the model.
Sure. We will promote it with the large companies that we are engaged with. Okay, great. Thank you, ma'am.
My pleasure.
Hi, ma'am. Hello.
Hello.
Can you hear me?
Yeah, I can.
Hi, ma'am. This is Dr. Sadhu from ICCW. I was working on my PhD was on microplastics. I just have an interest to know that what type of microplastic present in the textile water while you're treating it. May I know that?
So actually, your question has two parts, and both parts are related to two different projects. So we haven't tested microplastics in textile wastewater, because textile wastewater was only tested to develop this technology, upscale and all. Whereas as a separate project from Delhi government, we have begged a project. It was bidding. Through bidding, we got that project. We were superior in technology and L1 in the cost, and we bid and that project is on the study of microplastics in river Yamuna in Delhi and in groundwater in Delhi. So the kind of microplastics, just we have submitted the first interim report on the pre-monsoon sample. So I just can share you very brief results, because before presentation final, we cannot disclose the result. But overall, the whole answer to your question is we have got different kind of microplastics like fibers, films, different colors. So that kind of microplastics we have found in not. So what we have done, we have studied on the river, across the river stretch, then soil banks on both the sides of the river, and the areas, for example, landfill sites are there, plastic dump yards are there. So there we have seen that in the surface water, and then in the groundwater. So whole Delhi is distributed in 11 districts. So water samples, groundwater from all 11 districts have been selected. So results have come from that kind of detailed, and that is also first of its kind, such detailed and scientific study which we are doing in microplastics in the river in the country that way. Also,
How
we are
many?
looking and also we are looking at the percolation. So, how as a riverbed, soil and groundwater. So, how much the microplastics are leaching into the groundwater. So, that kind of study also we are doing.
Okay. Now, how many samples were collected from 11 districts, groundwater samples?
Yes. So, 11 districts, they are of varying sizes. So, the districts which are very large, so there, of course, we have to have 2, 3 hotspots, 2, 3 wells. So, this way, 21 samples were collected from 11 districts.
Based on which parameter you are selecting the locations for collecting groundwater samples?
See, there are Central Groundwater Board is there, and they
Okay.
have designated wells, and they regularly take the samples from there. So we have worked with them. We have gone because we can't dug this bore well and all, so we have
Yes.
to go by that. So we have the rationale has been the selection rationale has been on the existing bore wells and additional sites. So pumps where what you call these pumps are there,
Okay. Hand
groundwater
pumps.
hand pumps are there.
Hand
Then you have
pumps.
groundwater wells,
Yes.
designated groundwater wells by the groundwater board. So this is
Okay.
how we have done.
Okay, ma'am. Ma'am, I have one more question. Is there a possibility to know the percentage of plastic and microplastic in the treated water? Is there a possibility?
In the treated water,
Yes, ma'am.
so we haven't seen that as yet. We
Okay,
haven't.
okay, okay,
I would not say seen that. We haven't aimed that,
okay,
and we have just begun work because
okay.
microplastics is for the first time we are doing. So therefore, now as very interesting results are coming, and towards the end of the project is until next year, March, April. So maybe when the results may come, and when we get into much more details, then of course we can aim for the nanoplastics also. But as on date, we are focusing on the microplastics because that
Okay, ma'am.
itself is a huge range.
Yes, yeah,
Microplastics, so 100 micrometer to 5,000 micrometer, like this is the huge range.
yes, ma'am.
So that is enough in itself.
Actually, the reason why I asked this question is that there's a study in Chennai. There's a place called Ennur. In that Ennur, I did a study on that. We collected fish samples from Ennur. There's a place called Ennur Creek. While we
Okay.
are analyzing the edible part of the fish sample, all the edible parts were having the microplastic. So that is the nylon type. Since we are leaving the treated water back into Ganga, and the fishes in Ganga will be consuming it, right?
Exactly.
It will be consuming it because the reason is the size of the micro plastics will look like a small insects.
Yes.
So that is the reason the fish will be consuming all the microplastics, and which in turn will affect the health of the people who are living along the bank who are consuming the fish. So this
Can
is
you
the
see the
reason I
slide?
asked.
Can you see the slide?
Yes, ma'am. Yeah, ma'am. Yeah,
This
I can
is
see.
the type. This is the cover page of the first interim report, and here is probably the answer of your question. You can see these 11 districts of Delhi, and
Okay.
these are the kind of microplastics, fiber, films.
Yeah.
Majorly the fibers we are able to get, films in some cases.
Yes, ma'am. The maximum percentage is 5%.
Major, maximum
Yeah.
is fiber and various size and
Yeah,
all
and
the
colors,
microscopic
colors also.
colors also. All these studies, so such scientific in-depth studies we are undertaking taken, and these studies are done. These SM, EDEX analysis, everything is being done in CSIR National Physical Laboratory and highly specialized laboratories in the area. So this is, I hope you could get the answer of your
Yes.
question.
Yeah. Yes, ma'am. Thank you, ma'am. Thank you so much.
The report very soon. As soon as the project completes, we have just submitted the first interim.
Okay. Thank you.
We are open for any kind of collaboration, any joint work. Again, in this area of microplastics and micropollutants. So we can do this.
Yes, ma'am. Sure, sure,
And
ma'am. Sure.
Madam Sudha, and to the CEO, sir,
Yeah.
we have in the Center of Excellence, we have fellowships with us. We have
Okay.
money for the knowledge creation. Every government has
Okay.
funded that way. So we can also
Okay.
plan for joint research projects, small projects, and
Yeah.
PhD, funded PhD also. We can have it in the center.
Very good. Sure,
Yeah.
ma'am.
Yeah.
And I think our colleague
Looking forward.
Abhinami wants to ask some question.
Yeah, definitely.
Abhinami, you can
Yes,
unmute
ma'am.
and
Yes, ma'am. Very good evening. It's innovative, actually. It's a mind-blowing speech. First of all, I would like to thanks for this opportunity. Yeah, second thing is like when we are discussing about this microplastic, recently in Tamil Nadu Pollution Control Board, there was a symposium which was organized in Guindy. So when I had to go there and see for this related works, the report what was given was there's around 27 to 28 different types of plastics which is available. And in your technology, what you're proposing right now, just like to know, you've mentioned a word called from one pollution to another form of pollution we are recreating. That's a technology which is going right now. Can you just throw light on how is your TERI product, this product what is being launched from your side, will be helpful in not converting one form of microplastic to another form, rather it would be a sustainable one.
So again, your question is also same as Dr. Sadhu's. So technology is not aiming for microplastics. Microplastic study, all these are consultancy and research projects which are coming through the Center of Excellence. And technology is purely focusing right now on the wastewater treatment. So we are only looking at the parameters, standard parameters, BOD, COD, oil and grease, TSS, those standard 5-6 parameters which are there as per CPCB for the industrial wastewater treatment. Right?
Okay.
So, and when we talk of advanced oxidation, we all know it is purely for, as I have already shared, it is for the it's an oxidation technology, oxidation process for removal of organics and all that. Whereas microplastics is a separate issue. So those are two different things.
Fine, ma'am. Thank you. Thank you.
Thank you.
And
Ma'am, I
one
just
more thing.
wanted to.
Just one thing, Abhirama.
Yes, ma'am. Yes, ma'am.
So your answer, the question to your answer, when I say we are converting pollutant from one form to another and how this technology is mitigating to that is simply that if we are able to see reduce sludge drastically, not just minor,
Yes,
average 30 to 40 kgs and bringing to 0.2 to 0.5 kg per meter cube is, so we are less use of chemicals, less sludge, reuse of the spent catalyst. Are you getting?
Yes,
And
ma'am.
then,
I got it.
So we are first of all trying to reduce the pollution which we create. So one which is coming in the process, we at the moment that is coming, that is a separate study going on. Studies are going on how to reduce pollution or replace chemicals, hazardous chemicals into green chemicals. So that is separately mission is going on. We are working on whatever is coming out. Let us sustainably treat and help industries, municipal corporations. So our objective is purely to help the industries and the municipal corporations, ULBs, to meet the national targets or what is expected from them in the SBM or ZLDs or water vision, and all those government interventions.
Yes, ma'am. Yes, yes. Thank you. Thank you.
Yeah.
Ma'am, you were saying about the water body rejuvenation, Ishwar. So, is there any impact analysis that you have conducted after the intervention, how the things have changed post interventions?
So see, currently we are in the process of what you see is the technology is fully developed scientifically, technologically it has been developed. Now what we are doing is, for example, again I am going to share my screen for another purpose. So what we are currently doing is, this is another. So we have been applying this technology at small pilots for various applications. So industrial you have seen, municipal you have seen. This is the pond water. So this technology has also been adopted by the Office of the Principal Scientific Advisor to Government of India through DRIVE, Delhi region. So our technology details are also there on the PSA website. And when you see this, so with this now various gram panchayats, villagers are approaching us. So this one query we received from PSA office, and this village in Tamil Nadu, Namakkal village, this village in Namakkal district, and they had this problem. And this is a very common problem in villages. A lot of water is being accumulated over the years, and now it is impacting their health and all. So now we are applying through small pilots on the successful testing. So industrial, we have done more than 35 case studies, sewage, municipal sewage alone, then mixed sewage, all this. Now we are working on the pond rejuvenation, lake rejuvenation. So this kind of intervention, you can see such the water quality parameters. These are third party validation. We don't do testing. So all these are what you see the results of TEDx. So these kinds of interventions we are open drains. Again, this is a small drain passing through our own campus. And these are the interventions. So at the moment, we are our license agreements are very recently signed. And again, this is another area we are working on, wetland. So we all know nature-based solutions are always the best, but provided you have the space and that luxury space and the time. So, and today when country is talking of enhancing water reuse, so as a center of excellence on water reuse, our endeavor is to explore all possible areas where we can enhance water reuse. So this is from the root zone treatment, our own campus. First of all, we do all study everything in our own campus and our own water, and then we move out. So this is, you can see, physicochemical microbiology parameters. Just imagine root zone treated water. If you want to reuse it within the premises for various application, you cannot use it. However, with these micropollutant studies, so this is what we have done. So this kind of work is coming out. So we are yet to reach that stage where we can say, okay, the plant is installed and these are the benefits. So maybe next year when I'm there, by that time, if some installation is done,
Yeah, hopefully.
And I'm
Is there any groundwater?
Nandkumar
Yeah,
sir, Nandkumar sir, you must have seen the developments from last year when we were there in one panel and from this presentation. Mr. Nandkumar is there?
members.
No problem.
There is on the call, ma'am. So just
No problem. No problem. You were saying something, Ms. Sadhu?
So you have something to ask? No, I was actually trying to understand, like, was there any consideration of study when we are doing the water body rejuvenation on the groundwater, the aquifer of that area, or any kind of hydrogeology-based studies, whether we integrated with that?
Exactly. Actually, we submitted one report of landfill leachate in Banwari landfill area. You might have heard a very
Okay.
um, very prominent case. It went up to NGT, and
Okay.
we proposed a whole landfill leachate treatment plan, and that report was submitted to NGT, and NGT took cognizance of our scientific report and asked
Okay.
the Municipal Corporation of Gurgaon and HSPCB to not just involve this institute for the landfill leachate treatment, also involve this institute for groundwater to prove that groundwater is
Yeah.
not contaminated
Right.
because of your leachate. So this
Right.
kind,
Right.
so we gave a proposal which is under consideration, and again NGT took cognizance of that, and to assess groundwater quality around the landfill area, from right from the landfill to phase 1 up to 5 kilometers, and in phase 2 up to 15 kilometers. So these
Right.
kind of studies also the center is undertaking.
Okay. Okay. Very interesting technologies and information, ma'am. Really looking forward to collaborate with the possible projects that which we are
Yes,
also working towards.
definitely.
And, if there is no any other questions from the audience, I take the opportunity to thank you, ma'am. Thank you for all the time. Thank you for the accepting our invitation and sharing the knowledge. And we look forward to work with you. We'll just share
Definitely.
some of our project proposals. We'll discuss and we'll connect, and maybe wherever possible that we will work together.
Yes. And what I would like to also, my screen is still sharing now.
You're sharing something, ma'am?
Yeah. I'm just sharing one information like how to collaborate, like how will our collaboration be taken forward. So
Yeah.
in that case, what we can do, I'm just sharing again my screen. And if you
Yeah.
we have a, this is the website.
Yes, I could see.
NMCG-TERI Center of Excellence. And when you go to the website of the Center of Excellence, and all the details
Okay.
are there. This is the home page, and whatever I have shown is from here only. Here comes to the products and partners. So here all the products and partners. So even TERI and TERI Stadox technology is one of the product on the platform.
Okay. Right.
So COE is much bigger thing. So technology TEDx is separate and Center of Excellence is separate. So likewise, ICCW could be a partner, and you can see various companies, organization, even the schools, very progressive schools have joined us. Many more companies and research companies. IW is coming as a knowledge partner. And when you go to the partnerships, you have various 4 categories you can see here. So government partnerships, embassies are coming to us. Just morning we had a meeting with various embassies. It is going on, and government sector. You can see you come in the knowledge partner, right? As a knowledge partner, we can work that way. And when it comes to partnership engagement, there is no fees for the knowledge partners, only for the private companies who are profit making companies. If they are the partners on board in the COE, they have a 3 kind of membership, like standard, premium, elite. And membership, annual membership fees is 1 lakh, 3 lakh and 5 lakh only, and these are the benefits we give to the private companies. That's it. So otherwise, as a center, it's absolutely free as a knowledge partner, and you are welcome. Just one page, it has to be signed, and whatever we want to do as a collaborator, we can work in this domain.
Yeah, sure. Thank you, ma'am. Thank you so much.
And any other question, just let me know, write to me, and I'll be happy to answer.
Yeah, sure, definitely. Nanda sir, would you like to tell something regarding?
Chaitanya, he's still in call, so I can conclude.
Okay. Fine. Okay. Thank you, ma'am. Thank you so much. I'll write to you. I'll just discuss with Nanda sir also, and I'll convey your regards to Professor Pradeep sir, and you are being so inspiration to me and to many of other youngsters, and we'll collaborate. And I'll write it to you, ma'am, and I will continue the collaboration.
It always goes
Thank you.
this way. So I got my inspiration from Pradeep
Yeah,
sir,
yeah,
the Pradeep sir, and I'm glad with all these years, with 10 years hence,
yeah,
if I could do some humble work. So I'm
yeah.
really grateful. Thank you so much. I had a question. There is some question in the chat box. We haven't seen that.
Yeah. 1 second. I just know I got this one.
Question.
Collaboration, but I'll write to you, ma'am. So I think they were looking for some collaboration, so they said that they will write it to you.
Yeah, definitely.
Yeah,
Okay,
yeah,
thank you so
yeah.
much. Bye-bye. Thank you.
Thank you
Dr.
so much,
Thank
ma'am. Thank you so much. Thank you all. Thank you all. Bye, ma'am.
My pleasure.